Hey everybody, this is Larry. This is me doing contest, bi-weekly contest 156 as a virtual contest. As you may recall, I was traveling for a couple of weeks, very tiring, so I'm just slowly catching up. I think I only have a couple left. I have to double check, but either way, that's it. Hit the like button, hit subscribe button, join me on Discord. Let me know what you think about this contest, everything in between. This is going to be focused on the live cast or live recording or whatever. And you can definitely watch me. Explanations will be in their own video, is what I mean to say. And that's it. Let's get started, right? Thanks everybody. Oh, whoops. Have this thing up. Okay. Let's go. Let's go virtual. Am I ready? My notebook is it's over there. Okay, if I need it, I'll need it. All right, let's go. 5, 4, 3, 2, 1. Go, 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 go. I just realized I forgot to get X. Okay, well, let's go. Find the most frequent. Find the AIOU, the most maximum frequent, then the sum frequency. Of course, you only consider, okay. Therefore, T in number of keys. If K is in V, then we want to say wow is equal to 0, cons is equal to 0, maybe, right? Then what do I say? Wow is equal to max wow f of k. Otherwise, then it's a constant, it's equal to max constant f of k, right? What do we, sum of them? Okay. And that's it. What do I expect? 6 and 3. Let's go. I mean, that should be, I don't know. Maybe I could be a little bit more careful, but if I get that wrong, maybe I don't deserve to do it. Okay. Nums and non-negative numbers. Operations that all numbers are 0. Okay. So you may select subarray and set all occurrence of the minimum non-negative all occurrences of the minimum non-negative integer in that subarray to 0. Return the minimum. Okay, so you have 0, 2. So you select the 2 to 0. Okay, what is that? Okay, that doesn't explain anything though. 1, 3, 1, 2, 1, where the minimum non-negative number is 1. So don't we just always select it and order the entire array? I'm confused. Right? Because you just do it always to the order array, right? When would you not? I think this is just like a silly problem. Oh wait, this is weird. Oh, I see. Maybe I'm because if you set them, then it becomes 0, and then you have to do the other ones one by one because you cannot use them if it overlaps with 0. I see. Okay, minimum not. Okay, I was so confused. I was like, isn't that just the length of the things? Okay, then how do I want to do it? I was going to sort them because I didn't think it mattered, but now maybe I do. Do you always do one for all of them? I guess so. Well, okay, let's say Okay, so it's almost like a divide and conquer thing. I guess you always do it for the entire way because you can cross boundary anyway in any of your operation. So you do it once, and then it just becomes recursive, kind of, I guess. But you have to be careful to not make it n square. Huh, this is a medium, huh? 4-pointer. Am I missing some obvious thing? Because usually I expect this to be much easier. the idea is that you can cross boundaries, right? But and the max will take the max anyway. Okay, so I mean, so you do them in order. I don't get how that's fast enough though. Am I just too dumb to realize a smarter way? Huh. So first is that minimum you always want to extend, and then the, okay. So I guess that is the way. How do we make it not n square? And without like, huh. Basically you save moves within each of them. But, huh, I don't know that. How did 3,000 people get this one? And I'm cheating a little bit by knowing that, because I maybe could not have known that, but okay, so you always do, I guess that's the only, I mean, the algorithm I feel like makes sense. I just don't know how to assimilate it fast enough for it not n square. Stack? Is there a stack based thing? Okay, so let's say we go from left to right. Okay, we have a 1. Okay. And that's only because it's in the beginning, but otherwise, okay, so what's the min? Can we, I mean, from left to right. If it's bigger, you push on the stack. If it's min, then you pop everything in between, right? Okay, maybe that's right. I don't know. Let's see, right? Okay, so if length is stack is 0 to 0, then just stack that up and x, right? Otherwise, if it's bigger, okay, if it's bigger, maybe we just say 0, maybe that'll be helpful. Okay, so then now, if x is bigger than the top of the stack, then what happens? If it's bigger than the top of the stack, then yeah, you will late future do it, right? So here, okay, if it's equal to, then nothing happens because that's part of the current thing. So we continue. And then if it's lower, then now we keep on popping. Okay, maybe something like this. And then here we break, right? Here we also break. Otherwise, then if it's smaller, then we pop. Because then now they're no longer connected, and then we go again. Until it's one of these two. Maybe? Something like that? 1, 3, 4. Not super confident about this. YOLO submit. Oh, okay. That one's kind of hard to work out. I don't know how so many people got it so fast. Good job, people. Okay, rubber dag. represented by 2D array edges, UVW, given two integers k and t. Your task is doing the maximum possible sum of edge weights for what? Okay. Two integers k and t. You want a path with exactly k edges, and the total sum of the edges is strictly less than t. Return the maximum possible sum, which is less than t strictly. Okay, so if t is equal to 4, then on 3. It is a DAG, so there's no cycle, so you can. Okay. And we're given decay ahead of time, so that's nice. The number of edges, okay. I mean, that means that we probably could do some DP thing. Wow, n is 300. What does that mean? What is t again? 600. So maybe we have to do DP on that. What's k again? K is the number of edges. I mean, it's DP. I don't know. I want to write it down. Okay, so you have a current node. You have the number of edges used, and then you have t. I mean, that's gonna be too expensive, right? 300, 300, 600 is definitely way too expensive, right? Weights of I is 10 is maybe interesting, but maybe not. I don't know. Let's actually convert that first. Okay, right? It's a DAG. I mean, you could kind of root it and then everything else is just a difference. So you don't have to calculate from each node, which cuts off a lot of research. But this is definitely. I mean, this would be the naive thing, but that's definitely also way too big. Right? Okay, I mean the 300 nodes, 300k, that means that at worst you should be able to do 300 to 300. So that means that for every node, we should be able to get all the nodes. Is that right? So we can't do a buffer search from every node. I mean, it's still like delta thing, but I want to be DP, but I don't. Maybe it's not. Can I do a delta thing? Not exactly, I suppose. It has to be in the path. Okay, so let's say we do a search, right? But that, okay. Huh. 54 million is definitely too big. Can I do them simultaneously? Okay, so you start 300, you do one move each. I don't like bottoms up, right? And you do all the K at the same time. The T is do we want to max it? Well, I guess that's the tricky part, is that it's not a min on the rates. So that's not quite how you would do a buffer search type thing on the M and the K. The node and the K. I mean, unless it is like another bit set thing. Which I really hope it doesn't, because that's kind of lame. It is a DAG, so it will all progress. Let's give it a YOLO try. Okay, so what are we doing? Let's go at distances. Right. No, we can. Oh yeah. We're doing the bitmask thing, bitwise thing. Okay, fine. So then now it's actually all 1 because they are at 0 bits. Okay, that is confusing, but okay, fine. Right. So then now we go. Okay, so then now we run K times, maybe K plus 1 times, I don't know. No, so it's the number of edges. So if we run it 1 time, it's going to be 1 edge. So I think that's fine, right? So then now for I in range of n, and then now for let me tell for each time we do this, we actually just run, O of n plus e, so 600 plus, okay, maybe that's fine. In E sub I VW, let's just say no distances. No, I mean it's fine, right? So distances, possible distances. No, we didn't need distances. Right? New distances of v, because we travel to v, is equal to or shift by the distances sub I shift by W, right? Are we going to do bit set, something like that? Because it's all the way that you can get there and then W. Okay, fine. Right? And then distances is equal to new distances. Alright, does this even run? There's like some weird thing with mods and stuff, but Okay, fine, right? So then now, how do I even get like the most significant bit without doing, I guess 600 times 300 is not that bad, right? This is so silly though. I probably want to mod, but okay, fine. Right? Something like this. -1, I guess. And then now, okay. Okay, maybe I actually want it the other way. So for C in range of T minus 1 if for I in range of N, otherwise we return -1. If distances of I return C, something like that. Is it fast enough? I don't know. 320 am I right? Okay. YOLO submit. I wouldn't be surprised if this times out. It's very YOLO. Okay. Well, this is actually slightly more surprising. 22. That's weird though. Should be zeroed out. That's definitely not what I would expect. Actually, 66. From 0 to 1 with a rate of 3. So that's how you get to 8. And we want 22 steps or something. So that definitely shouldn't be right. Distances of we. Oh, why did well, it's a DAG, Larry. It's a DAG. It's a DAG. That's so dumb. Okay, well, I don't know what I'm thinking. I gotta stop doing that on autopilot on the DAG. So I write this like on autopilot, and so like I think that's why. Okay, I mean that's just a way. I don't know if I like that problem. It's a very weird problem. I don't know if you could do it without bit set or whatever, but I guess I'm not gonna find out until later. All right, let's take a look. How am I doing? That's not bad. I mean that didn't even really believe on that one, but okay. Let's see. All right, focus. Given an undirected tree at node 0, 0 to n minus 1, the tree is represented by 2D integer array edges of length n minus 1. It's a tree, of course. Okay, that's fine. Yep. Given an integer array of nums of length n and nums of I represents the value at node I. Okay, integer k. Okay, so we have a tree, we have a node value, and we have an integer k. Inversion operation on a subset of nodes subject to the when you invert a node, every y in the root subtree multiplied by -1. Okay, you may only invert a node if it's sufficiently far from any inverted node. Okay, you can write two nodes A and B such that one is an ancestor. Then must be at least k. Okay, maybe, I don't know. Okay, so we have this thing. We have k is equal to 2. Apply any number of inversion, is that right? Okay. We have edges. Okay, this one we can use I can't believe I got wrong answer on the previous one, because I was on autopilot. But okay. This one, it goes both ways, I guess. Well, but it's rooted at... Is it rooted? Rooted at 0. Okay, so we could root at 0. Okay. At node 4. Okay. So I guess this is like a DP on the tree or something. K is equal to 50 is useless, but okay. That's just like, maybe not actually. I don't know. All right. So, okay. What does this mean? Right? I want to say recursion in some way, but maybe okay. So okay, so we can go upwards, but we also go downwards, right? Meaning that if we invert a root, we cannot invert some number of nodes. So it's gonna be like, can I do something like node K, right? And it's the sum. Okay, I mean, I think one of my skepticism is why only 241 people got it. Because if this is the case, it shouldn't be that bad, right? Maybe. I don't know. It's kind of weird. Okay, because it just inverts everything, right? So, okay, right? No, total is equal to 0 for now, or best maybe. Yeah, I don't even know actually, because it could be negative. So I think maybe best is just negative infinity would be a little bit less risky. Okay, so then now we want to say, okay, invert this subtree, and then we don't, right? So we invert the subtree, then it is just this node, which is num sub node minus minus all the subtree, of course. So then we just do a loop through that. That's fine, right? And then if we don't, right? Well, I mean, yeah, and even that. Oh, we invert this. Oh, we invert the subtree if only k is equal to 0. So we invert the subtree. We go the children of go node, right? N times 50 should be fine, right? So all the children. Okay, I mean, this is a for loop, so we got it, I think. Okay, right? For v and y of node, if I'm going to have to go to this parent thing. If parent is not equal to node, then what is k is equal to 1? The distance must be at least k. So if it's k is equal to 1 means that number of edges. Okay, yeah. So 1 means nothing then, right? Okay, yeah. 1 means nothing, I think. But okay, that means you could do it every time. But then now, okay, let's just say total is equal to 0. If parent is not v, then total we add go v no k minus 1 maybe. Yeah, we don't take no invert. That means that right? But okay, just so new k is equal to k. If new k is minus 1, if this is less than 0, then k is 0. Okay, right? Total no. Okay, so that is that. Otherwise, we invert the subtree, so then it's the same thing, right? If total is greater than best, then best is equal to total. Okay, and then now we invert the subtree, which is the same thing. I forgot to add this node, so actually I'm wrong. Plus num sub node. Otherwise, total is equal to 0. Okay. Negative go we node. What be the this being k is not great. Okay, we'll just make a big k. That means that we have to go at least k. -1 for the edge, I think. Right. So then now, if turn best, right? And then we just return go 0, -1, 0, because we don't have any distance, and we are good. Maybe 993. We're not good yet. Okay. So this is 993. I have 9 and a 3 on trivial cases. That's good, at least. Why is this 27? Did I mess up the thing? No, I don't think so. Okay. K is 2. So we can do 0, 3, 4, 0, 3, 4, and 6, right? No parent. Total. I just say invert. No invert. Alright. No, okay, so let's see. Node 3. If we node parent and k, I think it's important. Okay, so 3, -3, alright. I mean, that's probably true. I see. The reason why this doesn't work is because we're maximizing the negative, so I have to do 2 functions, I think. I see. Because we have to get the max, the best, and the min, so that when we take the revert, we take the right one. Okay, I see. Because here we actually don't want the max, or maybe, well, this one maybe we do, but we return, if we return the min or something like that, then that's not good. I see. Okay, I just have to return 2 things then, right? Okay. I'll just okay, so then that means that we have how do I rewrite this? So if we don't invert, then we take the larger number, right? If we don't revert, No, I guess we just keep track of both. I guess it doesn't make sense to go. Something like that, maybe, right? This one I need. It's a little bit awkward, I think, but it's fine, right? Maybe I'm not super confident about what I'm doing, honestly. I think the idea makes sense. That maybe we have to keep track of it for the negative reasons. I thought it would cancel out in a good way, but maybe the min and the max function is kind of a little bit awkward. Okay, so then this we want to. So okay, the smaller number is going to want to subtract by the smallest number. I feel like I could have just written two functions, honestly. I think this is maybe not the best way to do it. Yeah, maybe not. Okay, fine. Let's reword this. Maybe I should copy it so that I don't have to do it again in case I am wrong. Okay, so then now, okay, so we did a negative. So we do the, we want the max, which means that we want the negative of the smallest, right? So go small maybe, and then this is go big. I think that's how I would do it. That's what I mean to do. Okay, so then now, if we're going big, then we just choose, we already have it done, right? Because we do negative of going the smallest. And then now we just have to copy paste to go smaller by changing the function, which I guess you can probably, if you're into functional programming, you could do a little bit better, but go small. So then now that means that we don't invert, we want to be the smallest, right? That means that if we don't invert, we still want the smallest. We do invert, then we want to go negative, go big. And I think that's it, except for I have to change this. We want to go small. So this best is going to be infinity. This is negative, negative. Let's just remove the print for now. Oh, we want to go big. I clicked on the thingy and now the thing is gone. Let me copy and is my internet down at the, okay, let me reset my internet real quick. Okay, that looks okay. Why am my computer asking me for things? Okay. Let's see. Okay, so that looks okay. Am I good enough to submit? Yeah, okay, why not? YOLO. If it times out, I'll be a little bit sad though. Okay. Yeah, not so bad. I don't know. I think I'm happier with the Q3, even though I guess I was a little slower. I mean, oh no, I mean, this one I thought was just ridiculous. I don't know that this is great per se, because it's team us and kn times t. But yeah, we'll go over that in its own video. But I'm just not thrilled about it. Yeah, that is all I have for this one. Let me know what you think. I don't really no crazy notes. I think I did okay, right? Yeah, I mean, I think the only thing I want to check is just the submission or how long things took, just to kind of see if I was cutting it close. Q4 is cutting a little bit close. I suppose Q3 is fine. I suppose silly mistake aside. But yeah, all right. I guess that is all I have for this one. Let me know what you think. Thanks for watching. Stay good, stay healthy, do good mental health. I'll see y'all later and take care. Bye bye.